Greatest mathematicians of all times. Let us quickly look at these two interesting problems from a branch of mathematics called differential calculus. Question 21. We are told that a particle moves according to the function h of t is equals to negative 2t squared plus 70t, where t is time in seconds and h is the height in meters above the ground. So h of t can be interpreted as the distance function for these particle that has been described in this problem. Then if we look at 21.1, they say we need to calculate the height of the particle after 5 seconds. So this is how we are going to answer that question. So 21.1, question 21.1. So the question says we need to calculate the height of the particle after 5 seconds. So we are given that the time t in seconds, it's equals to 5. So we are going to substitute this 5 into the distance function. So we are going to evaluate h of t when t is equals to 5. So we are going to substitute to get h of t, it's equals to negative 2 times 5 all squared plus 70 multiplied by 5. So this is going to give us 5 squared is 25 times negative 2 will give us negative 50. And then this will give us 5 times 0 is 0, 5 times 7 is 35. This will give us 350. So therefore, this tells us that h of 5 will give us 300. Therefore, the height of the particle after 5 seconds, the height of the particle, after 5 seconds, is 300 meters. The height of the particle after 5 seconds is 300 meters. We look at the next question, 21.2. 21.2. They say, how much time did it take for the particle to strike the ground again? So now we interpret this as meaning that h of t is equals to 0. When will the height above the ground be 0 again? Remember, the height above the ground will be 0 when t is equals to 0. So it means h of 0, it's going to give me 0. And then at some point, since this a particle follows a quadratic projectile motion, so at some point, after some seconds, the particle will return to the ground. So the question asks us to find that other particular time. So hence I equate h of t to 0. Okay, so that will give me negative 2t squared plus 70t, which is equals to 0. Then I'm going to factorize here. If I factorize, I'm going to factorize negative 2t. If I factorize negative 2t, I'm going to get t minus 35, which is equals to 0. Therefore, I apply the 0 factor law. Negative 2t is equals to 0, or t minus 35, it's equals to 0. And therefore, t will give me what? 0, or t will give me how much? 35. So the t is equals to 0 is the one that I was referring to here. So then after 35 seconds, this is the other time that they are referring to, after 35 seconds. So therefore, I'm going to conclude and say, therefore, the particle will strike the ground again. The particle the particle will strike the ground again. Will strike the ground again. The ground again after 35 seconds. After 35 seconds. After 35 seconds. So that's how we answer that question. The mathematicians, simple as that. We go to the next question, 21.3. 21.3, they say, what was the maximum height that the particle reached? So here we need to find the maximum height that the particle has reached corresponds to the value, to the y coordinate at the turning point of this distance function. So 21.3. So remember, we are given that the distance function of this particle is given by negative 2t squared, then plus 70t. Then, like I said, that the maximum height that the particle will reach will correspond to the y coordinate of the turning point. So I'm going to differentiate. This will give me negative 4t, then plus 70. So we know that at the turning point, the gradients of the tangent lines will be 0. Why? Simply because the tangents at the turning points are horizontal. So I will let the derivative of the distance function to be equal to 0. That will give me negative 4t plus 70, which is equal to 0. And therefore, this will give me t, it's equals to 70 divided by 4. And that will give us 35 divided by 2. It will give me 35 divided by 2. So therefore, this means that the particle will reach its maximum height exactly after 17.5 seconds. So the particle will reach its maximum height exactly after 17.5 seconds. 17.5 seconds. So now we need to find the value, the height that corresponds to 17.5 seconds. To t is equal to 17.5 seconds rather. We are going to calculate that. We're going to say h of 17.5 is equals to negative 2. We sub this into the original. Squared plus 70t. T will be replaced by 17.5. So I'll quickly work out these decimals. So we have negative 2 multiplied by 17.5 all squared. And then plus 70 multiplied by 17.5. Which gives me 612.5. I get 612.5. So therefore, this means the maximum height. This means the maximum height that the particle will reach. The maximum height that the particle reached is going to be 612.50 watt meters. The maximum height. The maximum height that the particle will reach. The maximum height that the particle will reach, is 612.50 meters above the ground. Above the ground. Okay, that's 2.1, 2.2, 2.3. Then 21.4, they say, what was the initial speed or the velocity of the particle? So this means I have to find what? Differentiate and then I have to find the derivative. In 2.1.21.3, I've already computed the derivative. So 21.4, the derivative says h prime of t is going to give me negative 4t plus 70. Now, the initial velocity corresponds to h prime at 0. H prime at 0 will correspond to the initial velocity of this particle, or the initial speed. So h prime of 0 rather will be minus 4 times 0 plus 70. And then this will give you how much? 70. So therefore, this means the initial velocity of the particle is 70 meters per second upward. So if we treat upward as positive, since this value is positive. Okay, and this is how we do question 21. This is how we quickly do question 21. Okay, so let's see. I just want to quickly highlight these answers here. We got h of s there, which was how much? 300, and then we give it an interpretation according to the problem that we are asked to solve. Okay, and then we have this time here, which is very important, the time there. And then we have this distance here, the maximum distance or the maximum height above the ground. And then here we found our initial velocity or the initial speed. Okay, that's great, mathematician. That's it. This is what I have for you, mathematicians. See you again next time. See you again next time, mathematicians. See you again next time, mathematicians. I'm just quickly scrolling here. Okay, I'm just quickly scrolling there. Okay, mathematicians. Get together, mathematicians. Sharp, sharp.